rule is generally taught alongside the sine rule. It's based upon the same standard triangle as drawn there. But the cosine rule is basically a variant of Pythagoras' theorem. Pythagoras' theorem says that a squared equals b squared plus c squared if a is the hypotenuse, that is, if vertex A is the right angle. The cosine rule extends this result so that it also works for non-right angle triangle. It puts a correction factor, if you like, onto the end of Pythagoras' theorem. People struggle to memorize this, but it's actually not too bad. Notice that whichever letter you have on the front as a side, something squared, a squared in this case, that corresponding angle appears on the end. So I could have written b squared equals a squared plus c squared minus 2ac cos b. I could have a b on both ends, or I could have a c on both ends. There are three arrangements. Okay, now then, let's consider an example and see what we can do with it. So, let's have a triangle that looks like this. Ten there. 8 there. 30 degrees in this corner. And let's suppose that you've been asked to work out x. You can label the vertices ABC, you can label the sides ABC if you wish, but however you do it, you eventually write this line, that 10 squared equals x squared plus 8 squared minus 2 times x times 8 times cos of 30. Now, what have we got? 100 equals x squared plus 64 minus cos of 30 is root 3 over 2. What we've got is minus 8 root 3 x. Now, looking at that equation and needing to solve it, hopefully you can spot for yourself that it's a quadratic. So for that reason, I'm going to subtract 100 from each side so that we have the necessary equals 0 for a quadratic. X squared minus 8 root 3 x minus 36. That's not very nice. Doesn't look like it's going to factorise, so we're going to reach for the quadratic formula. The quadratic formula says that x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. X therefore equals 8 root 3 plus or minus something all over 2. Reach for my calculator. 8 root 3 all squared makes 192. 4 times 36. This gives us the square root of 336. X equals 8 root 3 plus root 336 all over 2, which as a decimal is 16 2.1. If we use the negative instead, 8 root 3 minus root 336 all over 2, that gives me x equals negative 2.24. Let's do both of those to 3 significant figures. Now, that's all well and good, but you now need to go back to the context of the question and remind yourself what x was. X was a length, so you can't have a negative length. You show it in your working, you make sure that the negative 2.24 can be seen, but you also highlight the fact that you can't use it. The only suitable answer here is that x equals 16.1. Now, there are a couple of additional comments to make. First of all, and probably last of all actually, when we used the sine rule in a previous video, we saw that sometimes it will produce two answers. Let's have a look at the cos curve and just consider whether that's a possible outcome in the cosine rule. There's your 180 degrees. No angle in a triangle can be greater than 180 degrees. So we have positive results between 0 and 90. We have negative results between 90 and 180. The cosine rule will not produce an obtuse angle from the working.